Hello, GCSE Computer Studies students. In this video, I'm going to discuss strings and the fundamentals that you need to understand and learn. Strings are very important in computing. Most of the processing tasks that you need to do in your programming project, and certainly in a good selection of the written exam questions, will rely pretty heavily on string processing. So in this video we're going to look at the following: defining what a string is, understanding what indexing is, understand what we mean by the length of a string and how do we calculate that, understand what concatenation is and how can we use it, understand how to traverse a string, how to move through it, and understand what substrings are and how I can calculate those. Extension topics for my next video include immutability, methods, objects, and head-to-tail string processing, but those are topics I'll cover in the next video. So without further ado, let's get to it. The definition of string is simply an ordered collection of characters or an array of characters, an ordered array of characters. So a couple of important words here. The first key word is ordered, so it means the order does matter. Collection or array means there's a list of them. They are all contained within the same structure, and each of the elements in that structure is a character, by which we mean either an ASCII character or a Unicode character. So I can define in both pseudocode and OCR a string by assigning a variable, in this case s, using a single equals, and then in quotes, which can be single or double quotes, the value that I want to assign the string, in this case the word computer. Now, because I did mention that strings were an ordered collection, and that's important because it means each character within the string not only has an order, but it is also numbered. It is uniquely addressable as well. And computers always, whenever they can, will begin counting from zero, and just about every coding language out there will what we call zero base index or zero index its strings, and in fact its arrays as well. So this simply means that the first character is given the index position value of 0, the next character is then index position 1, 2, 3, 4, 5, 6, and finally 7. So my seventh character in my string S is the letter R, and I can index individual elements within the string by using the string name, and after the string name in square brackets, typing in the index that I want. So in the case I had here was S2 was equal to the character M. If I changed the 2 to another index value, let's suppose I go 4, then it'll mean go to the index position 4, which will in this case give me a U. So that is string character position 4, which is a U. Right, that's the definition of a string and how you can index it. Now, a word of warning. In many languages, notably Python and Java, strings are considered to be immutable types. So while it is okay to do a comparison like this, I can ask the question, is the character at position 2 equal to, notice double equals, M? That's quite alright, I can do that. However, I cannot change the value of a subtype, a subpart of that string individually. So I may not, even though I can index and talk about position S2 being M, I cannot assign or change the value. So I may not assign, for example, let's suppose I wanted to change this little m here to a capital M. I cannot write a statement like that. I'm not allowed to do that, because by immutable we mean that the string, once it is defined, is effectively read-only, and its subparts can't be assigned by subindexing. So I can't do stuff like this. We'll look a little later as to how do we get around this problem. Okay, but just important to know that you can't assign a subindex of a string a new character value. You can't do that. Right, the next main important concept is that of the length of a string. So as we said before, we start indexing from 0, but when we count, we don't start counting 0, 1, 2, we start counting at 1. So if I was counting normally, I would say, right, if I'm counting how many characters I have in my string S, I would say, oh, I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. And this is called the length of the string. So the length is how many characters there are in the string. Yes, I'm starting to index it from 0, and yes, the last character of the string is indexed by position 7. However, there are 8 characters, therefore the length of the string is in fact 8. We'll talk about the relationship between length and last character in a few more minutes. So how I represent this in pseudocode is I will go s.length, and that in turn will represent the length of the string s, in this case 8. In Python, Python doesn't use the method notation. Python has a function on its own, just like input is a function. This function returns an integer, takes a string as an argument or a parameter, and and gives me back the value of how many characters there are in that string. So the length of s in this case will be 8. Right, now we get to the business of understanding the relationship between the last character and the length of the string. Well, it's not that difficult if you think about it. Remember, length is simply counting how many characters there are, whereas indexing, we are effectively counting, but instead of counting from 1, we started counting from 0, and therefore the relationship is quite an obvious one. The last character is always indexed by the length of the string less 1. For example, my string computer has 8 characters in it, however my last index is 7. Another way of so the length of the string minus 1 is always going to give me the last index value. Another way of writing that same equation, so I could say that the length of the string is always equal to the last index plus 1. That's another way of writing the same thing. That's how I would write the relationship in pseudocode. So length s.length minus 1 will be the last index, and in Python the same concept applies, except I use the len function instead of s.length. So in other words, len s is equal to the last index of the string plus 1, or alternatively, I could say that the last index of the string is the length of s minus 1. And this is quite an important relationship. You kind of really just need to learn this one. Certainly understand it, but just learn it. It'll make life much easier for you. Right, the next concept is that of concatenation, which simply means joining two, or in fact more, strings together. And the operator that is used is the plus operator. And yes, effectively we are adding those two strings together. We're combining them, and they combine in the order in which you concatenate them. So if I go s equals letter C plus computer, it will join the C onto the front of computer to give me the word computer. The only difference between these two statements is that the blue one is pseudocode, and I'm using obviously therefore the double slash for the comment, whereas in Python I'll use a hash for the comment. Apart from that, everything else is identical. Traversal. Traversal is how I would go through and process a string character by character. So starting at character 1, then looking at the first character, which is indexed at character 0, then character 1, the second character, character index 2, the third character, and so on and so forth, all the way through the string, walking the string from the beginning to the end. How I do this in pseudocode is, remember, we are using a type of instruction known as iteration. Iteration simply means looping, and in particular we use a for loop. And the for loop looks like this. It starts with the word for. You have a variable, in this case x. I have the word to, and I end the loop with next x. In all my examples, I'm simply going to print out the value of the character at position x, and that's what my loop is going to do. However, I can replace this print statement with many other instructions, whatever it is I needed to be doing to the string. But for our example in this video, we are simply going to be using printx as the body of my loops. So pseudocode is much simpler to write than Python. So the only thing you need to understand is, right, what does the value of x represent? Well, the value of x represents the index value. So the numbers are the computer's numbering system of where the character is within the string. So the next two questions we ask about the answer is, where does that start? Well, the first letter of the string is always character 0. So therefore the answer is that the loop x must start at the value of 0 and then carry on all the way until the last value, which is 7. And that works fine for this particular example. What happens if I wanted to write something a bit more generic? Well, then I would upgrade my code to actually make use of the relations I know. Well, hang on, from the previous slide, I know that the length of the string is always 1 bigger than the last index. Therefore, the last index is going to be the s.length minus 1. And so I've simply replaced the 7 here with a more abstract notion that will always work regardless of how long the string is, and this is the preferred way of writing out a for loop for your pseudocode. For Python, we have to make use of the range statement. The range statement returns a subset of values, and if I only give it one parameter, one input value, the range will simply give me a list of numbers starting at 0 going up to whatever that number is minus 1. So for instance, so if I put in a 5 for range, I will get 0, 1, 2, 3, 4. It will never get to the 5. Notice, just like so, it's a very similar thing to the length of the string kind of versus the indexing of the string idea, and that's exactly how range has been engineered to make this sort of thing a bit easier. So range is going to give me the same number of elements as I give in terms of x. So if I make x 5, I will get 5 numbers. However, I'm starting to count from 0. Therefore, my last number that I'm going to print out is actually going to be a 4, or 1 less than the number I put in the bracket. So the for loop in Python works as follows. I start with the reserved word for. Please notice everything here is lowercase. I give my variable. I then use the reserved word in, and then the word range, and then I need to specify, or give the parameter, tell the parameter how many letters do I want to use. How many letters are there? Which is, in this case, well, there are 8 letters in the word computer. So I would simply enter the number range, and they would print out the entire string starting at character 0 going up to the end of it. If I wanted to be more generic about it, using length, remember the relationship that is that simply, well, I need how many characters on the string. Well, that's very, very, very easy. It's simply the length of the string. So the for loop for iterating over a string using indexes is always going to look like that. So instead of the 8, I simply replace it with the length s. Why do I not subtract 1? The answer is because the range function has been engineered to automatically do that for me. I do not need to subtract the 1 when I'm using the range function in Python. The last concept we need to talk about is that of a substring. Substring is simply a smaller part of a bigger string. Now, OCR defines a pseudocode. OCR pseudocode defines a substring method, which takes two parameters: the start index and the number of characters. Okay, so let's get into this. Let's have a look and see what this means. So, substring start index 3. That means go to character position 3. There it is, which is going to be a P, and then from that point, including it, count and give me a total of 3 characters back. So P, that's 1 character, U, character number 2, T, character number 3. So substring 3, 3 would give me back the value of PUT, or put. How would I do this in Python? Well, Python has no substring method or function, so it instead uses a concept called slicing. To make code between pseudocode, OCR pseudocode, and Python compatible, we can simply define a substring function as follows. So it's going to be a function that takes a string as a parameter, the start character as before, and the number of characters. And we simply use the slicing that Python allows us to do, which is saying, right, return the string S, starting at character start char, and going up to but not including the next parameter. This code, so I simply go that same value added onto that. Notice that I have to have indenting over here, and once I have my substring defined as a function, I can simply use it by going substring s, 34, which will give me the value of, if s is equal to computer, it'll give me the value of put, P-U-T-E. And that's the end of this video. I just want to quickly show you a little bit of Python here. Sorry about that. So there's my defined substring, just to prove that it works. No idea. Def substring is start index, run length index, and I just simply added, so I've kept that first parameter in there, and I've just added the second parameter onto the end of it and return that value, and I can just simply use it as it is. So if I now run this, as a result, I get put. And using the other example that I have in my video above, if I now change the value to 4, it's going to give me for the 4th character. Alright, let's try a few more other things with you. What happens if I start at position 4 and then do 4 characters? Let's see what we'll get back. I now get back Uta. Let's see why. Let's see if we can figure that out very quickly. So character 0, character 1, character 2, character 3, character 4. So that's where I start. So from there, and including the U, take 4 characters. So that's 1 I've got already, 2, 3, 4. There we go. Uta. That is my substring starting at position 4 for a length of 4. That concludes this video. Thank you very much for watching. Mr. Holmes signing off.